Hi everyone. Today we're looking at how do we use assume mean to compute our mean, standard deviation, and coefficient of variation. Okay, assume mean is a statistical method that is used to determine our arithmetic mean. Okay, when our arithmetic mean is not given, we use assume mean methods to figure out our arithmetic mean. Okay, and how do we do that? From a given set of data, okay, in the question, you can easily pick a number closer to the middle set. Okay, in this case I have 17 here. I can assume 17 is the assume mean. Okay, so I can use this assume mean, which is, let me say, am assumed mean. I can use this to determine my mean, to determine the arithmetic mean. Okay, standard deviation, okay, and coefficients of variation. Solution. I want to use this assume mean to figure out my mean, my standard deviation, and coefficient of variation at the same time. So let's start with mean. So how do we get mean? So the first thing we do is we have to look for all this set of data given to us, we have to look for what we call mean deviations. How do we do that? We have 12 minus 17, okay, followed by 14 minus 17. So we have 17 minus 17, followed by 20 minus 17, and we have 22 minus 17. So this gives us 5. 14 minus 17, sorry, this gives us minus 12 minus 17 gives us minus 5. 14 minus 17 gives us minus 3. Okay, 17 minus 17 gives us 0. This gives us 3. So 22 minus 17 gives us 5. Okay, so what we now do is we look for the sum of all these deviations. Okay, which is, the first one is minus 5. Okay, plus minus 3 plus 0 plus 3 plus 5. Okay, so when we add up all this together, at the end of the day, we'll be having 0. Okay, to determine our mean now, we say the assumed mean, which is 17, okay, plus the mean deviations, okay, and you divide this one by the number of observations. So when you divide 0 by 5, you still have 0, okay. So we have here 0, so our mean is 17, okay. So that is for number 1. So for number 2, we have to determine the standard deviation. Okay, and we always know that standard deviation is the square root of the variance. Okay, so for standard deviation, okay, we can say that is a square root of our variance, okay, which is summation of the mean deviation, square of it, divided by the number of observation. That gives us the standard deviation. So we have to determine the variance first. When we get our variance, we can now look for the square root to determine our standard deviation. So how do we do that? So for variance now, we can say our variance is, what we need to do is we'll come back to all these deviations. Okay, you look for the square of each of your answers, square of your answers. So for here you have, so for here I can say I have minus 5 square plus, I have to add it up. Here I have minus 3 square plus 0 square plus 3 square plus 5 square. So here I have 25, okay, plus 9 plus 0 plus 9 plus 25 divided by the number of observation, which is 5. I have it here. So I can say my variance, our variance is, when you add up this one is 50, with this is 68 over 5. This is our variance, which is 68 over 5. So from here, we can easily determine our standard deviation, which is the square root of our variance. So square root of this is our standard deviation. So I'll say my standard deviation equals square root of the variance, which is 68 over 5. So when we use our calculator to press this, we'll be having 0.6. So square root of 10.6 gives us 3.69. So this is our standard deviation. So for the coefficient of variation, which is, let me represent that as number 3, CV, coefficient of variation, is the ratio of our standard deviation to the mean. So our standard deviation is 3.69 divided by the mean. Our mean is given as 17, okay, times 100%. So when we times this, we divide this with our calculator. When we divide this, we'll be having 0.2165 times 100, okay. So when you multiply this with 100, having 21.71%, which is the coefficient of variation using Assume Mean method. Okay, thank you very much.